Okay, let's start the part 2 of the quantum mechanics, which is a strange property of light. So before you actually watch this video, I want you to actually take a look at this video right here. That's the equivalence of actually doing the virtual laboratory experiment. It's just going to tell you that light has a property of wave, but also having this property of particle. So that's that. And then here I'm going to actually introduce you the Planck's formula. And this guy right here, the Planck, used to actually work at the as a scientist, but the scientist that works for the sort of like a electric companies, and then that he was actually trying to find out what's the optimum temperature that you can actually optimum temperature to produce maximum light. So that's actually, he was actually involved in the development of the light bulb, the light bulb that becomes really hot ones, right? And then that while he was actually working on that particular topic, he found out that energy has to be quantized, and that particular formula that he found out was that E equal h nu. H is a Planck constant, and that nu, it's not v, it's not velocity, it's the frequencies here. So that, yeah, this is really somewhat confusing, but that's really frequencies. And F in Greek is R. Greek symbol is actually nu, looks like this. So that's E equal h nu, which is the formula he found out. And later on, that Einstein actually worked on this metal plate, and then that he shined the light, and then that he found out that the light have a particle properties, like it requires certain frequencies to actually pop the electrons out of the metal plate. And that formula that Einstein found was that the energy of the photon is h nu. So it's literally turns out that it comes out, it's exactly the same formulas, but the observations is a little bit different, right? The Planck actually observed using the thermal properties of the light, and then the photoelectric effect done by Einstein was actually done by the shining the light to the metal plate. But it turns out that E equal h nu is they both find out that E equal h nu is the key observations. So let's just use these formulas to actually calculate the energy of the photons. So let's just say that the tanning bed actually emit 350 nanometer wavelengths light, right? So we can actually calculate this particular light coming from these tanning bed, right? So the formula that we are going to use is C equal lambda nu, and lambda is the wavelengths, and then nu is the frequency, right? And then that's speed of light. But we don't really have the frequencies, but we do actually have the wavelengths, and that wavelengths, remember that speed of light is 3 times 10 to the 8 meters per second, right? That means that we're gonna have to use the meters on this guy too. So what is 350 nanometers? 350 nanometer is actually equal to 350 times 10 to the negative 9 meters, right? So that's fine. I'm just gonna put that things in here. And then try to solve for this guy right here. So let's just use Excel to figure out what it is. So one side I have 3 to the 8 meter per second, right? That's the speed of light. Light speed, right? And then the wavelength is actually 350 e to the negative 9 meters per second. Meters, sorry. Then we can actually get frequencies right here. What is the frequencies? So to get the frequencies, C equal lambda nu, right? Then nu has to be equal to C divided by lambda, right? So let's just do that one. So that's equal to speed of light divided by wavelength. So that's the frequencies. What's the unit? Per second. That's what the hertz right here. So we got the frequencies that's required to actually solve the problem, because the energy of the photon is Planck constant times the frequency, right? The Planck constant is given by that number right here. So let's just use that one right here. So the Planck constant is 6.63 e to the negative 34. That's 6.63 times 10 to the power of negative 34. That's in joule per second. The joule is a standard unit. It's kilogram meter square per second square. So you don't have to do anything about this one. And frequency is given by that one, right? So energy is equal to h nu. So all you have to do is multiply that one and that one, right? So is equal to that. Is equal to that one times that one. So that's energy is in joule, right? So that's the answer. Notice that I really didn't use your conversion formulas like this, right? Putting something here, and so on and so forth, right? What I did was that I changed the unit before you actually use the equation, and then put the numbers into the equation. And this way of actually solving the problem is actually much faster than using this type of stuff, because you don't have to write so much of the stuff. So I want you to actually convert your way to solve the problem into my way of solving the problems. That's probably the end of this slide.